Hi, my name is Jeremy Cothran. I'm doing a presentation called Sqlite for AI, or Artificial Intelligence. Play on this is persistence of memory for less than 250 kilobytes, based on the Salvador Dali art piece. What is Sqlite? From the sqlite.org website, Sqlite is a software library that implements a self-contained, serverless, zero-configuration transactional SQL database engine. It's very widely deployed because it's used in a lot of smaller embedded devices, and the source code for Sqlite is in the public domain. The attractive points to Sqlite are that it's a 250 kilobyte executable that runs against flat files, and the files can be as large as the file system allows. It's a relational database using structured query language, and structured query language supports CRUD, create, read, update, and delete type table records and operations. Why would you use SQLite? It's an open source, lightweight, and easy to install database for smaller embedded systems, e.g. handhelds, iPhones, Android, and Palm Pre. Proper search index usage supports fast, on the order of milliseconds, queries across millions of records. Spatialite, which is a SQLite extension library, supports search indexes and spatial functions against geometric data types, such as points, lines, and polygons. Also, SQLite is a simple file-based persistent storage layer, allows simulation configuration parameters or other run results to be easily transferred between users or various runs or processes. A SQL or SQLite approach might also be an easier initial approach for developers that are relational database and SQL familiar. Why would you not use SQLite or SQL? SQL and relational databases place a focus on data structure and ease of query, which may work against your overall efficiency depending on the environment or task, or in other words, using the right tool for the right job. For example, high-end gaming machines that might have a high-powered GPU might favor more unstructured, homogeneous raster set data types for parallel processing. Here are some simple structured query language statement examples. Creating a table called item, which would contain item records or rows, with each record having a name and a cost associated with it. Writing a data record into the table for a hammer at the cost of 5, and then selecting rows from the item table that have the name hammer and have cost greater than 3. sqlitebot is an open source project using a SQLite database to help manage and inform the bot decision-making process. The initial demonstration is simply to write data to the database with game data and then read that same data back out as it might select the bot behavior. A second demonstration shows the ability to use evasive or hiding behaviors based on earlier pre-game gathered visibility records. Pogomud is the second open source project which provides a Java NetBeans IDE developer interface for interacting and programming Unreal Tournament bots. The manner in which this is done is that the Unreal Tournament game sends messages to the GameBot API, and those messages are communicated to the Pogomud interface, which translates them into Java objects. Let's start with a look at the Pogomud Java NetBeans IDE interface to controlling the bots. The Pogomud interface project has a main method, which includes a do logic loop for controlling the bot and doing various things that are related to the bot state, such as engaging the enemy, or shooting at them, or pursuing them, or collecting items on the map, and so on. The interface also has a control for starting and stopping the bot, and also a server control for selecting different maps that are available, controlling the speed of the gameplay, or sending commands to the GameBot API to add bots or remove bots, or so on. Let's take a look at the game itself. This is a test map that I created just for some very simple beginning behaviors. It's basically just an empty room with a couple of nav points and a rectangle around a main wall, and rocket pickup and ammo pickup on the corner. So we can add a bot. I can start bot. The bot will appear, and we can follow the bot if we want. As it travels between the nodes, we can see the bot's health, the red indicator in the middle, indicating 100% health, and we can add site vectors to see what the bot is looking at. And now I can enter the game, and I'll let the bot kill me 3 times. The way the script currently works, it records the locations of the place where the bot was killed or got a kill, and will return to those locations for further action. So now the bot's killed me 3 times and is looking around in those former locations for more action. And it'll continue to run in this loop for about 45 seconds to a minute, just a parameter I set, after which it'll give up on those spots. This slide shows the database tables used in the simple demos. An observation table, which contains the game data type used for making decisions about where to return to in the game based on a certain event, such as a bot kill or death. And a navpoint table, which relates back to the bot what nav points or waypoints are visible from other nav points or waypoints. Here's some sample Java code describing how we do a write or insert to the database. We start with connecting to our database by describing the JDBC class and path, and connecting to the database, preparing the SQL statement with the information provided by the event, and then executing the SQL statement. This results in the rows being written to the database, and we can select those back via another SQL statement like below. This slide shows getting that data back from the database that we've just written, doing a select statement. Again, we connect to the database, set up our SQL statement. In this case, we want events of a certain type that have occurred within a certain time range on a certain map level, ordered by their entry date in descending order. We execute the SQL statement, and then we can take the result set that we get back and apply a random method to it to get back a random row from that result set. This second clip is a pre-game process the bot goes through to establish a visibility index on each nav point by slowly turning and processing the game messages regarding visibility and putting that information to the database lookup table. Currently, it's a brute force process where the bot travels from each nav point to nav point, establishing the relative visibility of nav points. Ideally, it would be nice to have this generated from the game geometry itself without having to use this brute force method. This last game clip shows how I'm changing the quality of the bot behavior to be evasive if it gets below a certain health level. I've set the health level to be when the bot gets below 70 health, it will evade me rather than attack me, and which it's doing right now. It got injured and is fleeing from me based on the earlier navigation point visibility index. So whatever nav point that I'm closest to, it understands that and understands the navigability from that related nav point and goes to a nav point other than the ones that I can see to evade me. And the bot is now regenerated and is pursuing me, and I think I get killed here in a second. Yep. And now the bot's health is low again, so I'm on the chase again, and the bot is again fleeing and trying to stay out of my view based on the nav point that I'm closest to it at the current moment. This slide shows a sample query against the navpoint table just to give an idea of what's returned from the query against the navpoint table. This one shows a query for where the navpoint ID equals 1 and the other navpoints which are visible from that navpoint. And this slide shows how we're creating an evasive or hiding behavior from the bot by using this navpoint table. We create our SQL statement, which gives us the nav points which are visible from the enemy nav point, the nav point which the enemy is nearest. We run that query, process that query into a array list, and then if the array list is not empty, we compare a random location against our array list of visible points so that we make sure we get a point which is not visible. and further ongoing information.